Okay, from the previous videos, we've been trying to transform our data. In this video, we shall be now fitting our data into the model. Since our data is now ready, we've transformed, we've made all the necessary transformations. So let's start. Alright, let's first start by, so we're fitting model, tuning the model, and predicting using the test data in this video. So we first start by splitting our data into the train data and the valid data. So from Kaggle, Kaggle told us our train data is until the end of 2011, and our validation data is 2012 and 2013. So we followed that, and we have split our data into 2011 and that is not 2012 and what is not 2012. So let's run this cell and see the length. Alright, so you can see the length of the validation data is this, and the length of the train data is this. So we have more rows in the train data than the validation data. So after splitting our data, the next step, we try to split our data into X and Y. Thus we are splitting it into the features and the labels. So we were splitting both the train data and the valid data into the features and the labels. So first we will split the train data into X train and Y train. So X train is the features, then Y train are the labels for the training data. So that's all the features, excluding the sales price. Then this is only the sale price. Then now also the valid data we do the same. So let's try to run this now. Shape shows us the shape of the different data data sets. So here, like for X train, we have shape is 400. Now these are the number of rows by the number of columns. Then we only have one column. We only have one column. All right. So that is that. So let's proceed. After we've split our data, we have the train, we have the validation data. We've split it into the features and the labels. Now it's now ready. We can fit it. We can now fit our model. So import our. All right. Before that, our evaluation, building the evaluation. Now evaluation. Kaggle told us it's the root mean squared log error. But now we're using scikit-learn. Scikit-learn doesn't give us a root mean squared log error evaluation, but it gives us something called mean squared log error. Basically, the root mean squared log error is just the square root of the mean squared log error. So here we create a function that's going to return for us a root mean squared log error. Yeah, that will take the y labels, the labels that we've given, that we've been given against the predictions. All right. Then after that, function. Now we just we don't want to, because we shall be trying to evaluate our model time and time over. So just try to create a function here. So the function basically is going to take the model, and after that it makes predictions using our validation data, and then it returns for us predictions. Then now those are the predictions we use to score the evaluation. So we call our function the root mean. So we store this into a dictionary. Then we call the function. Then we input the validations, the labels plus against the predictions. All right. So those are just functions that shall be using. So now let's try to train our model. Let's actually train our model. Now in this model, I'm training only. I'm using a sample of 10,000 samples. I don't want it to take a lot of time. I don't want it to take a lot of time if I'm to use the whole data set. So I'm just using 10,000. So now at least now we've trained a model. We've trained a model, a random. Up here we imported. Remember we've already imported. We'd already imported our scikit-learn model that we're using here. So here we've trained. Now we have a model that is trained. We've trained it using 10,000 samples. Now let's try to. Now we've just described this model, so let's try to fit it. And also we want to see how much time it's going to take. Running that cell, it tells that it's taken 1 minute 16 seconds. And now let's try to evaluate. Let's try to evaluate our model by running this. Alright, we've not run all the cells. Alright, then we run that, then we did not run that cell, then we run that, then we fit, then now we score our model, evaluate our model. So it's taking some time because it's still trying to fit these samples into this. So let's try to wait for a few seconds. Alright, so it took 36 seconds. Then so now evaluating our model, we're falling at 0.29. the root mean squared log error, it's 0. So let's try to improve. Let's try to improve. So our goal is to make this value as low as possible. If it can go lower than this, then our model is more accurate. Remember, we've just used 10,000. We've just used 10,000 samples. So let's first try to tune our model, and then again we can train it again and see how we perform. So here we are putting something called randomized search CV. This is basically used to tune the different parameters in our model. So we're creating the model here, and then we're using randomized search CV, and then we're using random forest regressor. Then the parameter the param distributions, so it will come and take all this. Now these are just the different hyperparameters that we're trying to tune. So then after that 20 times, then cross validations 5 and above. So if we run that, it's going to take us some time. So it took 12 minutes 15 seconds. Then after that, now we have our RS model trained. Now let's try to look at the best. So now let's try to look at the best parameters from tuning all these parameters. Let's try to look at the best performing parameters. So how we do that is like this. All right. Now after that, let's just try to score our that model that we use to the tuning. So it's it's that has again increased, so that's not good enough. Now let's try to retrain our model using this best parameters, this best performing parameters. So again, we use random forest regressor. So we're calling our model ideal model. Then now we're using all this. Then now we are fitting now using all. So here we are now using, now we're training our model with the best parameters, but now we're using all the sample rate. We not remember the first one we just used 10,000, but here now we're using all the data set. So it's taking some time. This is going to take some time. So let's just hold on. All right, that took some time. It took almost 2 minutes. It took some time. So now, after training, after fitting that, now let's try to evaluate. Let's try to evaluate our model and say, all right, now this is now better than our first training, where we trained using only the 10,000 samples. That was around 2 point. That was around 2 point. As you can see, that was 2.9. So at least now we have our model is now at least we're now scoring 0.29. Now let's try to do some manual tuning too. Now here you see, let's just try to tune the n estimators. Let me just increase it to 30, and we try and see how it performs, if it's gonna perform better than this or it's going to perform worse than that. Let me run that. So let me run this. I'm just naming it a first model, so it's taking some time. It took 3 minutes. 3 minutes. All right, anyway, now we've trained our model. Now let's try to evaluate and see how it performed. 2.5. How was the previous one? 2.5. So it's performing better. So you can see just by tuning that the n estimators from 20 to 30. We're performing good. 0.2525. So let's try to again compare how good the leaderboard. Let's try to see how the leaderboard was, how good these guys performed. All right. Okay. I'm not connected to the internet, but this is where we would probably see the leaderboard, how they are performing. But anyway, our model is not that bad performing, because I saw earlier on, and at least we would have a good ranking. So now after that, let's try to after we've trained our model. We've done some tuning in it. Now at least our model is performing well. Now why don't we now predict the prices of the test? Why don't you predict the prices of the test CSV? All right, let's do that. So first we start by importing our test CSV as a data frame, but we're passing this as a date. All right, let's run the cell. All right, that also is taking time. So we have 52 columns. And 12,457 rows. All right, that's a small. It's not all that big, and we have integers. So we have ints, object. All right, now what we're going to do next is we have to transform all the transformations, whatever we did to our training data set. We have to do it to our test data frame, so that we have the exact format. So all the processing that we did, I've just put this in a function, but all this is what the transformations that we did. We added columns. You remember when we added these columns? Then after that, we dealt with then we dropped this. Then we looked for the, then here for the, we're changing the strings into categories, and then here we're checking for the columns, for the features that were numerical. And after that, if there are nulls, we're creating a column and a binary column, and after that we're filling it with a median. Then for the categories, we converted them to that. So basically that's what we're also going to do to our test data. We process the data by putting all the transformations, doing all the transformations that we did into our train to this. So let's do that. So this is the function I just created, and we store it in the test data. All right, processing. Okay, it's now 10. So now after transforming, now we've transformed our test data. We're trying to make it, we're making it look like our trained data, so that we can use it for predicting. So we try to look at the difference of our training data and the test data, and we say that we're missing one column, this feature. Now why are we missing this feature? Why we're missing this feature is, remember when we this is a numerical, and let's try to see what this is. So it's a numerical. It's a numerical action ID is numerical. So this we generated from this one, but now in our training data we're transforming. Remember here we had a function in the numericals. If it has missings, that's when we applied this. So now our data, our test data, it so happens that it doesn't have nulls, it doesn't have missing. So that's why this was not applied to it. This was not applied to it. So we have to, now what you're going to do is to we're going to add that column, but false, because now all of them are present. For the action ID, nothing is missing. So we create sort of a binary, just as we did in. Now after that, let's try to look at the length. So all of them are now the same, all the columns are the same. So I think now we're good too. Now let's also try to see the set. So nothing is, in both cases, the extrain and our test data, nothing is missing. So in the next column, now here we have to arrange our test data, the process test data, because now since it has the exact number of columns like our training data, but now it has, before we can predict a sell price, it has to be in the same exact order as our trained data. So that's what this column is doing. Sorry, sell. So now we've arranged, now all of them are in the exact format, and even the features, the order of the features are the same. Now let's predict the prices using now we're going to use our best performing model, which was first model. We predict that. All right, now after predicting, now we format. Now we format our data. We format our data in the format that Kaggle wants us to format our data in. Kaggle wants us to format our data. Kaggle wants us to format our data in the sales ID for a validation set in this order: sales ID and the sales price. So we create an empty data frame. And after that, we add the cells ID, and we extract that from our test data. Then we also add, now these are the predictions, we also add it, and we have that. Let's run this and see. All right, now that's the format that Cargo. So now from this we can just save it into a CS, we can save it into a CSV, and we can upload it. So the cells ID 1, this is the prediction of our price, all of them until all that. So now after that, now we're done with our project, but now one thing remaining is feature importance. So feature importance, this is a question that you can be asked, like the features, the different column, what are the features that contributed most when we're training our model, right? Feature importance, what features, what columns were most important when we're training our data, right? So scikit-learn just provides us a very simple way of doing that. We just use the model and feature importance, something called feature importance. And so, all right, this is an array. It puts them into a NumPy array. So this is representing the first feature until the last one. So let's try to visualize that. Let's try to visualize that in a graph. So Seaborn is also for visualization. Then this is the function that is going to plot for us a graph. So it's going to take the columns and then the feature importance, but we want it to just create to plot for us the first 20, not all the columns, the first best 20 performing columns. Those are the features. So we create a data frame with features, then it's taking in the columns, the importance, then ascending is false, then we reset drop, then we, okay, all right, all that. So now let's plot. So we're feeding it with our X-train columns. These are the columns. Then now the importance. Let's run that and see. All right. So you can see these are the features and these are the feature importance. So you can see that our the feature that contributed most is the year it was made, obviously, which is important. Then the next one was the product size. The product size also contributed very much to our model predicting the sale price. And there was something called F-base model. So you can again check this from our data dictionary Excel sheet and try to understand what the features. But basically that is it. So these are the first best 20 perform features that contributed towards. So we could upload this to Cargo. With this, we've come to the end of our project. Just now we have a fully functioning machine learning model, and we have also gone ahead. We've trained the model. We worked on our data. We transformed our data. We were able to see some insights into the data. Then we've trained our model. Then we've tuned our model. Then now we have made predictions according to a data set that was provided to us. And now this marks the end of our project.